Okay, now we finished section 2.3. Now let's go to section 2.4. And we're starting from 54, 57. So 54, so in 54, you are asked to find the domain for the square root function. So I'm going to skip 54, okay? So we have the function f of x equals to square root of 5 minus x. We did. So I'm going to skip this one. But if you want me to do, I can help you. But does anyone need help here for 54? Okay. Now let's see 57. And 57. Now we did 57 also. It was pretty similar. We had a absolute value function, and this is also absolute value function. You are actually find the domain, so I'm going to skip this one as well. So 57, then 61, 62. Okay. 61, 62. So in 61, we had to determine whether the graph is a function or not. And what do we use? Like what test do we use to check whether the graph is a function or not?
Horizontal line test.
No, that's for one-to-one function. We use vertical line test. Okay. So in 61, we have like a different graphs. So one of the graph is, yeah, this is. So you draw a vertical line. Okay. And if your vertical line crosses the graph exactly at one point, then the function is the graph is a function, but here the vertical line crosses at 3 points to this, so this is not a function. Okay. So if you have a graph that looks like this is a function, it crosses exactly 1 point. Okay. If we have something like this one, this is not a function. You draw the vertical line, okay? And if your vertical line crosses more than 1 point, then your graph is not a function. So that's 61. Next, we have 62. Okay, so in 62, we need to find. So you are given a graph, okay? Like from 62, in 62, you are given a graph and you are asked to find. Okay, I think it's a super easy. I think I'm gonna skip this one. So you have a graph, okay? So let me draw that graph. So here, so you have a graph. This point is -3, 4, and this point is -2, +2. This point is 1, 2, and this point is 3, -2. And you are asked to find f of -2. What is f of -2? Your input is -2 and you are looking for the output. It means when your x is -2, what is y? That's the question here. So when your x is -2, our y is +2. So 2 is the answer. Similarly, you are asked to find f of 1. F of 1. So when your x is 1, your y is 2. 2 is the answer. Similarly, you are asked to find x-intercept, y-intercept. And x-intercept is the point where the graph crosses the x-axis. This is the x-intercept. And y-intercept is the point where the graph crosses y-axis. And this is the y-intercept. Okay, so this is what you have for number 62. Now the next you have 63, 64. Okay. In 63 and 64, determine if the equation describe y as a function of x or not. Okay, so in 63, we have 2x plus 3y equals to 6. Now, is this function or not? 63, what do you think? So to be a function, what is the condition? For every x value, we need to have exactly one y value, right? If you have a two y values for one x, then it is not a function. Like you have a set here. Am I sharing my screen?
Yes.
Okay. Okay. So for example, you have 2, 3, 4, 5, 6. 2 corresponds to 5, 3 corresponds to 5, 4 corresponds to 6. This is a function, right? Every x value, this is x, this is y. Every x values has exactly one y value. If every x value has exactly one y value, it is a function. But if 3 also corresponds with 6, then this is not a function. Okay. Now for 63, what do you think? Do you think this is a function?
Yes.
Okay, this is a linear, right? Linear equation, and linear equation is a function. So you can just rewrite in terms of y. So y is equals to, so when you solve this, you're gonna get something like -2/3x plus 6/3. Okay, so you choose your x value, okay, and you find the y. And if for any one x value you can find two y values, then it is not a function. So since this is a linear, and linear is always a function. Now here, so we have y squared plus 9x equals to 0. Or you can graph, okay? That's the other way. If you have a graph, you use the vertical line test, okay? So that's the one way to find whether the equation is a function or not. Now in this function, if you choose, now is it possible to have two y values for one x value? Okay, so I can rewrite this as a 9x equals to negative y square, like if I subtract y square on both sides. Now, if I choose 1, what would be x value? X value would be, if y is 1, x value would be, so you substitute here. So you have negative, so 1 square is 1, and you have your x would be -1/9. And if you choose -1y, what would be your x value? If you choose y equals to -1, you substitute here. So we get -1 squared is +1, and you have -1, and you divide by 9. So you still have the -1/9. Okay, for one x value, you have two different y values. And you can't have this. So this is not a function. Okay. Does anyone have question here? 63, 64. Okay, now let's go to the next one. We are at 67. So in 67, find the variation constant and the corresponding equation. Okay, for 67, y vary directly as x. And if y varies directly as x, the equation is y equals to k of x. Okay, if it varies inversely, then y is equals to k/x. So y varies directly as x. Okay, so y is given as 25, x is 10. So k times 10. You divide both sides by 10. So we have 2.5 equals to k. Now you substitute k into this equation. You have y equals to 2.5x. That's for 67. 69. Okay, number 69. Y varies inversely as x. So inversely means you are writing y equals to k/x. You substitute y equals to 9 is given to you. K is unknown. X is given as 6. So you multiply both sides by 6. This cancel. 9 times 654 equals to k. You substitute k into the equation. So you have y equals to 54 over x, and this is the equation. Okay, do you have any equation for these two numbers, 67 and 69? This is 69. Okay, now let's go to 71, 72, 73. Okay, in 71, if the revenue of a wallet manufacturer varies directly with the quantity of wallet, so wallet revenue of the wallet, so let's call R as the revenue for the wallet, and it varies directly with the quantity of wallet. So directly means it is k time quantity of wallet, and let's call that as a q. Okay, you can just name it anything since it's a directly related. So this is how we write the equation. Find the revenue function of the revenue from selling 5,000 wallets. Okay. Okay, if let me read this one more time. So if the revenue of a wallet manufacturer varies directly with the quantity of the wallets sold, find the revenue function. So this is our revenue function. If the revenue from selling 5,000 wallets is 30,000. Okay, so you are selling 5,000 wallet and your revenue is 30,000. Now, finding revenue function means you have to find this k value. Okay, you need to find this constant value. So when so you have 30,000 revenue by selling 5,000 wallet. Okay, your quantity of wallet sold is 5,000. You find the value of k, you divide both sides by 5,000. So this is gone. This is gone. 5 times 6 is 30. So your k is equals to 6. Now you substitute k equals to 6 here, and you have the revenue function. Your revenue function is 6 times q. This is the revenue function. And what would be the revenue if 800 wallets were sold? Now, when your quantity sold is 800, you are asked to find the revenue. You substitute q equals to 800 here. So R is 6 times 800, and this is $4,800. Do you have a question here? Okay, no question. Now let's go to number 72. In number 72, the demand for a product is demand for a product is inversely proportional. So let's call D for a demand is inversely means you have a constant divided by inversely proportional to its price. Let's call P for a price. If 400 units are demanded, so 400 is demanded at a price of $3 per unit, how many units are demanded at a price of $2 per unit? Okay. Here, our demand is inversely proportional to the price. If 400 units are demanded at a price of 3 per unit, so it means our demand is 400 units, K is unknown, and price is for $3. Let's find K. You multiply both sides by 3. This is 1200 equals to K. Okay, now let's substitute this K value in our demand function. So our D is equals to 1200 divided by price. The second question is how many units are demanded? It means you are finding demand. How many units are demanded at a price of 2? So when P is 2, what is the demand? That's the question. So demand is 1200. So that's not the 1200 divided by P is 2. And this is 600 demands units. Any question? Do you have a question for me for these numbers? Okay. That's good if you don't have questions. Now let's go to number 73. We have in number 73, the following table gives the value of computer printer purchase in 2012 at two different times. So time we have in 2000. So the table gives the value of computer printer purchase in 2012 at two different time. Okay, so when time is 2 year after purchase, okay, so the computer has been purchased in 2012. So after 2 year of use, the price, the value of the computer is $300. After 4 year of use, the value is $200. The question for you is express the value of a printer as a linear function of the number of years after its purchase. So we are asked to express the value of printer as a linear function of time. Okay. So here, let's call our function value of a value function as a v. Okay, so this is a function here. And this is pretty similar. So, okay, so you have 2 point here, 2 and 300. This is 1 point, and 200 is the other point. And you are finding the equation of a line joining these 2 points. Okay, now let's call this is x1, y1. This is x2, y2. And we know how to find the equation of a line joining these 2 points. To find the equation, we need a slope m. Slope is y2 minus y1 divided x2 minus x1. Y2 is 200 minus 300. X2 is 4 minus 2. We have 200 minus 300 minus 100 divided by 2. This is minus 50. Slope is minus 50. Now we find the equation y minus y1 equals to m times x minus x1. Y minus y1 is 300 equals to slope is 50, x is x, x1 is 2. Simplify, you distribute 50. So we have negative 50x, negative 50 times negative 2, positive 100. You are adding 300 on both sides. So your y is negative 50x plus 400. Now this is in the general form, okay? You have to have the specific x and y. Now what is your y for our case? What will be y and what is x? Your y is the v function, okay? So in your y is v. So our v of t, since we are expressing in terms of time, so v of t is equals to negative 50. Your input is x. For our case, our input is time plus 400. And this is the expression which give us the value of a printer. Okay, do you have a question here? Okay, this is part A, okay? In part B, using the function, now we are using this A function, find the original purchase price. Now, what does it mean by finding the original price? So in order to find the price, we need to know the time. Now, what is the time? How do we know the time in order to find the original price? What will be the time?
The time would be 0 in the beginning, right?
Yes, we purchased our computer in 2012, okay? And T has been defined as the number of years from 2012. Okay, finding original price means we want to know the price, the value when our time is 0. So you substitute T is 0 and you get the value of computer original price. So B of 0 is negative 50 times 0 plus 400. And this is $400 is the original price, okay, purchase price for this computer. Now for part C, assuming that the value of the printer is a linear function of the number of years after its purchase, when will the printer's value reach $0? So our function is p of t is negative 50t plus 400. So this is the function. And we are asked to find when. It means we are asked to find the time the printer value is $0. It means v of t is 0 given to us. So 0 equals to negative 50t plus 400. So you subtract 400 on both sides. So you have negative 400 equals to negative 50t. Divide both sides by negative 50. So this is 8. 8 equals to t. Now, after 8 years of a purchase of a computer, its value is $0. Now, what is the year? You are asked to find when. Yeah, when means yeah, you have to find in what year. Now, how do we know what year? Your time is 8 years after purchase. You purchased in 2012. And after 8 years means it's gonna be 2020. So in 2020, the price of a computer is $0. Okay, and yeah, I think I think you will have a pretty similar question. Okay, like out of this, we did 3 different real life problems. So make sure you practice these. Okay, you'll have one. Okay, do you have any question up to 73? Okay, now let's go to 77. In number 77. Oh, we need to decide the function is odd, even, or neither. Okay, in 77, and also we are doing 79 as well. 77, 79. Okay. So in 77, we have a function f of x equals to negative x squared plus 5. And in 79, we have f of x equals to negative 3x to the power 5 minus x. And we are asked to decide whether this function is even or odd. Okay. And whenever you are asked to decide the function is even or odd, what are you gonna do? There is a very common step. Okay. You're gonna substitute negative x for every x in the function. Okay. For both of these function, you substitute negative x for all x in the function. Okay, so let's replace our x by negative x. So we have f of negative x equals to, we have negative as it is, you replace this x by negative x, make sure to have parentheses, e square plus 5. You do the same thing for 79. F of negative x equals to negative 3 as it is. For x, you're gonna replace negative x to the power 5 negative. You're gonna replace this x by negative x. So if you are asked to decide, or if you're asked to check whether the function is even or odd, is the step. You replace your x of a function by negative x. Now here f of negative x is equals to, we have negative as it is, negative x squared is positive x squared plus 5. So here f of negative x is equals to negative 3, and the fifth power of negative x is negative x to the power 5th, right? So fifth power of negative is negative, and x to the power 5th is x to the power 5th. Negative times negative x is positive x. Now, what is this expression, negative x squared plus 5? Isn't this expression same as f of x? It's same, right? See, f of x is also negative x squared plus 5. So we replace this expression by f of x. So we have f of negative x is equals to f of x. Now here, f of negative x is equals to negative 3 times negative x to the power 5 is positive 3x to the power 5 plus x. Now, if you have, now you have the decision here. So when after replacing your x by negative x, okay, if you get the same f of x function, then the function is even. So our function is even. Okay. So after replacing x by negative x, if f of negative x is equals to f of x, then the function is even. Now here, to be odd, okay, to be odd, if f of negative x is equals to negative of f of x, then the function is odd. Okay, after replacing x by negative x, if you get f of x as the negative of original function, the function is odd. Now I can rewrite this function as so I can factor out a negative here. So if I factor out negative, I have negative 3x to the power 5 negative x. Does anyone have question here? I factor out negative from each expression. And once you factor out negative, the sign of each term changes. So we had positive here, so it changed into negative. We had positive here, it changed into negative. Now, what is this expression? This expression is our f of x. See, this is f of x. So we have f of negative x is equals to negative f of x. And if this is the case, the function is odd function. Okay, sometimes the function may not be even nor odd. Okay, so you can have a function which can be even, odd, or neither. And this is how you use the same method. Okay, you replace your x by a negative x. If you get f of negative x equals to original function, your function is even. If you have f of negative x is the negative of original function, your function is odd function. Okay, do you have any question for 77 and 79? Okay, looks like we don't have any. Now let's go to 83, 84, 85. Okay. In number 83, 84, 85, you have a graph and you are asked to write an interval where the function is increasing, decreasing, or constant. Okay, now we have 10 more minutes and I have to start the new meeting. Okay, now, do you think that you need help with this one? So you have a graph, okay, and you are asked to write down an interval where the function is increasing, where the function is decreasing, and where the function is constant. If you want me to do, yes, I will. Otherwise, I'm going to skip this one. Does anyone need help with this? Writing an interval where the function is decreasing or increasing. I'll just choose one different function, okay, not the graph that we had here. I'm not going to draw that, but I'll just give, for example, we have this graph here, and our graph is like this one, this, okay. So here, let's say this point is 1, 4. This point is 5, 4. Okay. Now, if we have this graph, now can you tell me the interval where the graph is increasing? Every time you are like, whenever you are asked to write down the interval where the function is increasing or decreasing, you are starting from the left. Okay, so since your graph can be extended all the way to the left, so on the left we have negative infinity. So when you move from negative infinity to, so you are moving along the horizontal axis. Okay, you are writing the number, you are using the x coordinate to write down an interval, not the y values. Okay, so when you are moving from negative infinity all the way up to positive 1, our function is, the graph is rising, right? It means this is, the function is increasing. So from negative infinity to positive 1, you are using x value, positive 1, the graph is increasing. Now you are at 1. Now when you are moving from 1 all the way up to positive 5, there is no change. The graph is constant. So this is the interval from 1 to positive 5 is the interval where the function is constant. Now you are at 5. Now you move from 5 to all the way past infinity. Your graph is again rising. It means this is the interval where your function is increasing from 5 to infinity. The function is increasing. Okay. Can you all do the 83, 84, 85? You have a graph there, okay? And you are asked to write down the interval where the function is increasing or decreasing, okay? So I'm going to skip this one. So try to solve with the help of this example. And if you still need help, yeah, just let me know. Okay, so next we have 85, 87. Okay, what do we have here? 87. In 87, you are asked to find the average rate of change of f. Okay, the formula will be given to you. Yeah, okay, I'm not sure. Okay, so for 87, you are asked to find the average rate of change of a function in the interval 3, 4. So we have this interval. Okay, let's call this is x1, this is x2, and we are asked to find the average rate of change. Okay, and your average rate of change, what is the formula here? Is it, okay, if I'm not wrong, is it f of x2 minus f of x1 divided by x2 minus x1? And if you are asked to find the average rate of change, the formula will be provided, okay? Can anyone just make sure, is this the formula for average rate of change? I think, okay,
I think so.
Yeah,
Yeah.
okay, thank you for confirming. Okay, now you have your x1 and x2 here. So let's substitute our x1, x2. So we have f of x2 is 4 minus f of x1 is 3. And 4 minus 3. Now you have the graph, okay? And you find f of 4 from the graph. And from the graph, f of 4, when x is 4, our y is 1. So f of 4 is 1. Okay, you have the already graph, so you can find f of 4, which is 1. And when x is 3, what is y? When x is 3, our y is 0. Divided by 4 minus 3 is 1, which is 1. 1 is the average rate of change, okay? And this will be provided to you. Okay, that's number 87. If you have any questions, please let me know. Now we are at 88, 89. Okay. So in 88, you are asked to find the y-intercept. Yeah, you just look at you have the graph and you are looking at the point where the graph touches y-axis. Now, in number 89, you are asked to find the average rate of change. Okay, it's pretty similar to 87. But in 89, you are given the function. So you have to find, okay, like for in 89, so you have a function f of x equals to negative 2x plus 4, and the interval is 2, 3. You are asked to find the average rate of change. So you call this x1, you call this x2. The formula is f of x2 minus f of x1 divided by x2 minus x1. Okay, so we have 3 more minutes. Now how do we, okay, let's substitute x2, x1. So f of x2 is 3 minus f of x1 is 2 divided by 3 minus 2. Now we have this function. Now you are using this function to find f of 3. How do you find f of 3? You substitute 3 for every x. So negative 2 times 3, negative 6 plus 4, which is negative 2. Negative. Find f of 2. You substitute 2 for every x. Negative 2 times positive 2. Negative 4 plus 4, 0. Divided by 1, which is negative 2 is the average rate of change. So this is 89, okay? The next is 91 and 93. What do we have in 91, 93? 91 is also the same, okay? You are finding average rate of change. So I'm going to skip this one. In 93, given function f and g, find each combination of function and identify its domain. Okay, let me do this one. For 93, our f of x is given as 4x squared plus 1. G of x is equals to x plus 1. Okay. And I will, okay, so this is gonna take time. So let me go ahead and end this meeting, okay, because we have like around 2 more minutes left. So let me end this meeting and please join back, okay? Then we'll start 93. I'm gonna end this meeting.